Okey, baik. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning everyone. Welcome back Mukris, Intan, Aisyah, Aina, Abdullah, Taufik, Catherine. Ramai juga ni kan masuk ni. Damia pun dah ada. Alright. So many. Rizky pun dah ada. Okay, very good. So untuk hari ni kita akan continue dulu mengenai radioactivity. Last week we have discussed about the structure of an atom kan. Kita discuss when an atom loses an electron or receive an electron, it will become ions. So sekarang ni kita nak tengok pula kita nak discuss pula about ionizing radiation and non-ionizing radiation. I will have to change slide first. Alright. Okay. So, since we have discussed about formation of ions, since we understand that when an atom receives or loses an electron, it will become ions. When it loses electron, it will become positive ion. When it receives an electron, it will become a negative ion. So let's take a look at this video. It is a good introduction to two different types of radiation, which are ionizing radiation and non-ionizing radiation. Cuba tengok dalam video ni, apakah karakteristik of both types of radiations, either in terms of, ada tak dia cakap pasal macam mana dia boleh menyebabkan ionizing, bahaya, kalau dia bahaya tu macam mana, dari aspek apa, ada tak side effects bila terkena ionizing radiation atau non-ionizing radiation, and so on and so forth. Ya, kita tengok dulu.
Ionizing radiation, which is energy that's given off by radioactive materials. Ionizing radiation has a lot of energy, much more than the low energy radiation from radio waves, cell phones, and microwaves. These types of low energy radiation are called non-ionizing radiation. Ionizing radiation has potential for interacting with and changing atoms and molecules. This is an important distinction which many people may not realize. For simplicity, we'll just refer to it as radiation. If radiation hits the cells in the body, it can damage or even kill the cells. The amount of energy that the body absorbs from this radiation is called the radiation dose. At high doses, and when most of the body is exposed, enough cells die to impair the function of various organs in the body. And that can lead to really serious health effects, including death. If only a specific part of the body is exposed and the dose is high enough, it could lead to localized effects, such as skin injury. At low doses, if any cells are damaged, the cells may repair that damage with no consequence. Or the cells may leave the damage unrepaired or repair it incorrectly. And these may have long-term consequences and could potentially increase risk of cancer.
You used the word exposed. Is this term used differently for radiation hazards than other environmental hazards?
It is. When our bodies absorb the energy from radiation, we're being exposed to radiation. We don't have to come in contact necessarily with any radioactive materials. If we walk away from the source of radiation, the exposure stops.
So like with an X-ray, you're exposed while the X-ray is being taken, but you don't take any of the radiation home with you.
Exactly. Now, in contrast, if radioactive material gets on our clothing, skin, or hair, it contaminates us. We call this external contamination because it's on the outside of our bodies. External contamination can be removed simply by taking off contaminated clothing and washing with soap and water. If we inhale or ingest radioactive material, we call that internal contamination because it's now inside our bodies. It's harder to remove internal contamination. Our bodies can get rid of some of it through metabolism and excretion. And for some types of radioactive material, we have medicines. We call them countermeasures that can speed up the excretion process. Ionizing
Okay, so based on the video just now, what are the things that interest you? Atau ada tak apa-apa yang kamu rasa macam okay, I want to know more about this, I want to learn more about this? Atau what are the questions that goes unanswered bila kamu tengok video tu, kamu macam ada lagi persoalan-persoalan yang perlu dijawab berkenaan dengan ionizing radiation and non-ionizing radiation ni. What do you think? Apa feature atau what are the characteristics of radiation discussed in the video? For example, ada tak penyakit-penyakit tertentu yang dibincangkan dekat sini yang make sense to you? Misalnya were exposed to radiation, apakah penyakit-penyakit yang, apakah kesan dia kepada sel kita, ataupun what does it mean by contamination of radioactive materials? Ada tak yang menarik perhatian kamu masa kamu tengok video tu? Right. Okay, I can see some ideas here. Ada yang tertarik dengan apa yang berlaku kepada sel-sel badan kita apabila exposed to radiation kan. So antara apa yang menarik minat saya masa melihat menonton video tu ialah bila dia sebut sebenarnya radiation ni ada dua jenis, ionizing and non-ionizing radiation, but usually for the sake of discussion kita refer to ionizing radiation tu as simply radiation lah. Tapi kita tahu yang non-ionizing radiation pun exist in our environment kan, but kita sebut ionizing radiation tu more frequently because it affects our cells. Seperti it can damage or kill cells, yes, and then it causes us to have an increased risk of cancer. I agree with you. And then exposure to radioactive materials can be external or internal. External sebab when we are bombarded with X-rays radiation, the radiation tu will pass through our body kan, and then and that is also maybe why whenever we took an X-ray, we have to change our clothes kan, tak boleh pakai kita punya clothes, kena pakai hospital clothes kan. And then when he said about ingesting radioactive materials, itu adalah antara treatment yang cancer patient kena buat lah. Sebab tu when antara step dalam treatment dia tu, atau dia nak buat MRI ke apa, dia kena ingest a bit of radioactive material so that it can be detected by the machines kan. Alright, so thank you so much for your feedback. Saya ada tulis titik-titik banyak tu, saya pun tak Saya pun risau juga ya bila dia tulis titik-titik banyak tu. Okay, so as mentioned in the video, there are two types of radiation. The first type is ionizing radiation. It is when a radioactive radiation passes through the air and produces positive and negative ions. So when it passes through the air, the neutral air will become ionized air. Whereas for non-ionizing radiation, it is an electromagnetic radiation that does not have sufficient energy to ionize atau to remove electrons from atoms or molecules. So non-ionizing radiation ni adalah radiation yang kita guna dalam kehidupan seharian. For example, for radio frequency, and then microwave, visible light, and also infrared. However, when the range goes up to when the radiation goes up pergi ke arah formation of X-ray, gamma ray, so dia dah masuk dalam kumpulan ionizing radiation. Tapi the wave that we use in our daily life, for example radio wave, infrared wave, microwave, those are the wave that we apply in various electrical appliances. Those are non-ionizing radiation. So here is another video regarding ionizing radiation. So tadi tu kita tengok secara umum different types of radiation, but this video discusses specifically several characteristics of ionizing radiation. The four characteristics are the natural characteristic, maknanya nanti bila ada formation of alpha ray misalnya, what are the number of protons and number of neutrons released because of the formation of alpha ray, beta ray atau gamma radiation. What are the charges of the particles, adakah dia positif, negatif atau neutral. The ionizing power, tinggi, rendah, sama juga penetration power, tinggi atau rendah. So let's take a look at the video and we will discuss further about these four characteristics.
We saw in the last video that each element comes in a number of different forms called isotopes, each of which has the same number of protons but a different number of neutrons. Importantly though, only one or two of an element's isotopes are stable, while the rest of them are unstable and so can undergo radioactive decay, which is where they emit something so that they can change slightly and become more stable. So when we say that a material is radioactive, all we mean is that it consists of unstable isotopes that can decay. In this video, we're going to take a closer look at the four types of nuclear radiation, namely alpha particles, beta particles, gamma rays, and neutrons. And we'll cover how ionizing and how penetrating each of them are. Let's start with alpha radiation. Alpha particles are made up of 2 protons and 2 neutrons, which is exactly the same as the nucleus of a helium atom. So we normally represent alpha particles with helium's nuclear symbol, He. Importantly though, alpha particles don't have any electrons, so they have an overall charge of 2+ from those 2 positive protons. Because they are relatively large, alpha particles are easily stopped by collisions with other molecules, which means that they can't penetrate very far into other materials. In fact, they can only travel a few centimeters in the air and are absorbed by a single sheet of paper. However, their large size and their strong charge does make them very strongly ionizing, which just means they can easily knock electrons off any atoms that they collide with. Next up, we have beta particles, which are just electrons. So they have a charge of -1 and virtually no mass. Now, the weird thing is that electrons aren't emitted from one of the atom's shells. Instead, one of the atom's neutrons decays into a proton and an electron. The proton stays in the nucleus, but the electron is emitted out at high speed. Because beta particles are pretty tiny, they're moderately ionizing, and they penetrate moderately far into materials. For example, it would take several meters of air, or about 5 millimeters of aluminium to stop them. Now, gamma rays aren't particles at all. They're actually waves of electromagnetic radiation, like light is. And they're often emitted after alpha or beta radiation, as a way of the nucleus getting rid of a bit of extra energy. As they don't have any mass or charge, they tend to pass straight through materials, rather than colliding with any of the atoms, which makes them only weakly ionizing. This means that they can penetrate really far into materials before being stopped, so it can travel long distances through air, and it takes thick sheets of lead, or multiple meters of concrete to stop them. The last type of radiation we need to look at is the emission of a neutron, and there really isn't much to know. If a nucleus contains too many neutrons, which is making it unstable, it can just throw out a neutron to increase its stability. So to quickly recap, alpha particles are made up of 2 protons and 2 neutrons, and will be stopped by a single sheet of paper. Beta particles are just an electron, and can be stopped by a thin sheet of aluminium. And gamma rays are electromagnetic waves, which require a thick piece of lead to stop them. That's everything for this video though. So if you found it useful, then do give us a like and subscribe, and I'll see you next time.
Okay, so tak tergelak pula bila subtitle tu tulis pizza particles ya. Basically this video discusses about 4 types of ionizing radiation, which are alpha, beta, gamma, and also neutron radiation. So what interests me about the video is when he talks about beta particles. Beta particles form from the movement of electron. But what interests me is that the electron does not come from the electron shell atau electron orbit yang kita discuss sebelum ni. When we discuss about formation of ion before this, electron that move in and out of an atom causing it to become ion tu from electrons that live atau resides on the orbiter. Kan kita ada lukis struktur atom. The middle of the cell consists of neutron and proton, whereas the surrounding nucleus tu ada orbits containing electrons. But interestingly, beta particles, the electron in beta particle does not come from the electron shells outside the nucleus, but it comes from neutron that decays to form electron lah. So that is why it is different from simply donating atau receiving electron. Is not the same as the movement of electron when the atom is donating atau losing an electron, but it comes from the decaying process of neutron inside the nucleus. So dia juga ada sebut pasal penetration power, which is related to the relative heaviness of the particles. Dia sebut dekat situ alpha is the heaviest, relatively heavy lah compared to beta, and then due to that the penetration power of alpha is low compared to the others lah. Let's take a look at the table that discusses these characteristics. So based on what we have observed just now, can you complete this table? What are the natural characteristics of each radiation? What are the charges of each, the particles of each radiation? The ionizing power, tinggi ke, rendah ke, moderate ke, and also penetration power. Which one is the strongest? Which one is the weakest? Okay, so let's take a look at one sample answer here. So thank you Intan for your submissions. Tinggal baris bawah sekali tu je dia nak buat kan. Alright, so kejap ya. Alright, see here. Okay, so when we talk about the different characteristics of radiation, there are 6 characteristics that we will take a look into. Lagi 2 nanti kita discuss at slide 8 and slide 9 ya. So for alpha radiation, kita tengok apa all of the characteristics of alpha radiation. Alpha radiation, the natural characteristic is since it contains 2 proton and 2 neutron, it is always symbolized using the symbol helium He. And as mentioned in the video before, since the alpha radiation, even though it is similar to helium nucleus, it does not have electrons. So it is positively charged. But the ionizing power, when we take a look at the ionizing power of alpha radiation, it is high. But since it is heavy, the penetration is low. For beta radiation, it is consist of high speed electron. Electron ni datang daripada the decaying process of neutron. So since it is consists of electrons, so the charge of the particle is negative lah, and the ionizing power is moderate, and the penetration power is also moderate since it is slightly quote unquote lighter compared to alpha radiation kan. And then finally, let's take a look at gamma ray. It is an electromagnetic wave that is released together with alpha or beta radiation lah. as mentioned in the video just now, it is used to release excess energy due to the formation of alpha and beta radiation lah. So since it is neutral in nature, the ionizing power is low. However, since it is lighter compared to alpha or beta radiation, the penetration of gamma ray is higher compared to alpha and beta radiation, and as shown in the diagram over there, it requires a very thick material, lead setebal 10 cm baru boleh stop the radiation of the alpha gamma ray radiation. Sebab itulah we can see here the difference in characteristics can be due to whether it is positively charged or negatively charged or neutral, and also it is due to the quote unquote weight of the radiation, of the particles in the radiation, kan? So alpha tu dia paling berat sebab dia ada two types of particles, proton and neutron, followed by a bit lighter beta radiation because it consists of electron. Okay, ada dua lagi characteristics yang kita belum discuss kat sini, which are when the rays atau the radiation pass through electric field. Okay, so when the radiation pass through electric field, okay, saya bagi ability for you to draw here, for you to take notes lah. There are no questions here, yeah. So let's take a look at this particular diagram. So bila the source of radiation emits alpha radiation, apabila sumber radiasi itu membebaskan alpha radiation, alpha ray, gelombang alpha, gelombang alpha tu akan bergerak across magnetic field, mula-mula straight, lepas tu dia membengkok kalau kita tengok gambar ni. Okay, so kalau kita tengok dekat sini, okay, apabila radiation tu bergerak merentasi electric fields tu ada, kalau kita tengok pada gambar rajah tu, the lines going arrow yang dilukis dari atas ke bawah tu adalah lines that represents electric field lines. So due to the presence of electric field lines ni, dia akan menyebabkan setiap satu ray tu dia punya pergerakan tu akan terjejas lah. So as we take a look at alpha source, since alpha radiation atau alpha ray is positively charged, jadi bila alpha radiation masuk ke dalam electric field, it will move slightly towards the negatively charged plate. Sebab alpha tu sifat dia positif. Jadi mula-mula dia straight, lepas tu towards the end of the electric fields baru dia start skewed to the dia start bergerak ke arah negatively charged plate. So since alpha ray ni dia slightly heavier, so dia punya deflection tu atau dikonal ke arah negative charge plate tu agak lambat lah, sebab because of its heaviness when compared to beta source. Since beta source is electrons negatively charged, so the movement towards the positively charged plate tu occurs earlier compared to alpha radiation, because beta source ni dia lebih ringan daripada alpha radiation, so dia bergerak ke arah positively charged tu lebih cepat. For gamma ray, since gamma ray is neutral, so when it goes through electric field lines, dia tak ada deflection pergi ke mana-mana lah, dia tak pergi ke negatif atau positive plate because it is neutral. So it goes through electric field lines unaffected. Bagaimana pula dengan magnetic field lines? So for magnetic field lines, where similar to what we have observed before, gamma ray dia akan go straight. But for alpha ray atau alpha radiation, it will move upwards while beta ray will move downwards. Okay, well beta ray will move downwards. Okay. Sekarang ni kita dah tengok 1, 2, 3, 4, 5 dan 6 characteristics of radiation, ionizing radiation. So let's take a look at this particular slide discussing sources of ionizing radiation in the environment. Can you give at least 2 examples of natural sources of ionizing radiation and man-made resources or man-made sources of ionizing radiation? Okay, kejap ya, I show responses. Alright, boleh tak bagi at least 2? Alright, I can see here some of the sample answers. So the two the two examples for natural sources of ionizing radiation are cosmic rays and background radiation. Very good, thank you Melissa. And then the sources for man-made ionizing radiation can be from nuclear accidents atau nuclear tests. Misalnya during the World War times, each countries very developed countries at that particular time keep testing different types of atomic bomb kan, causing the emission of ionizing radiation. Misalnya macam antara tempat yang famous yang untuk buat nuclear test ni ialah Bikini Bottom lah. Bikini Bottom tu is a real place where nuclear test is conducted. Bikini Bottom bukan saja wujud dalam SpongeBob universe saja. And then nuclear accidents such as Chernobyl, lepas tu masa tsunami hari tu di Jepun, dia punya nuclear plant ada leakage of ionizing radiation from the facilities kan. And then ada juga yang kita memang sengaja gunakan seperti the use of radioisotopes, different radioisotopes for medical purposes, and also ionizing radiation ni juga wujud dalam bentuk background radiation. So when we talk about cosmic rays just now, when you stated one of the example atau one of the sources is cosmic ray. So when we talk about cosmic ray, it is basically a high energy radiation produced outside the solar system or from another galaxy. These cosmic rays are known as galactic cosmic rays. When we talk about background radiation just now, yang man-made tu kan. So it can be man-made atau it can be natural lah macam cosmic rays ni. So it is made up of the combination of various types of ionizing radiation in the environment which are released from various sources. So it can be from cosmic rays, tapi cosmic rays ni bila kita berada di atmosfer, kesan dia akan lebih jelas lah, akan lebih tinggi as we go outwards towards the space. Kalau macam kita kerja dalam airline company ke, so this will affect us lah. And then radioactive radiation from naturally radioactive substances that exist in our surroundings. Misalnya kita discuss pasal carbon 14 hari tu kan. So it is naturally radioactive substance that exists in our surrounding as well. And then radioactive waste from nuclear accidents and nuclear tests, and radioisotopes from medical users. So radioactive waste from nuclear accidents ni dia akan, sebab kita dah discuss mengenai half-life kan. So radioactive waste ni have a very long half-life. So it takes many years for the emission of ionizing radiation from the radioactive waste to start to decrease to a level where it is safe for human to live in that particular area lah. So kalau kita tengok dekat Chernobyl tu masih lagi, walaupun dah berlaku berpuluh tahun, masih lagi tidak selamat untuk manusia tinggal dekat situ because of the very long half-life of the radioactive materials used in the power plant. Okay, so untuk ionizing radiation ni, okay, there is a specific unit that measures background radiation. So statement 1 until 4 adalah statement that is related to measuring background radiation. Can you complete these statements? Okay, boleh tolong lengkapkan statement ni, ada 4 ya. Oh lupa, apa ya saya nak sebut hari tu? One of you asked me about our exam paper. So regarding exam paper tu kita hold dulu. Sebab semalam bila dia tanya saya kata saya akan announce dalam kelas kan. So kita akan hold dulu kita punya exam paper. Saya masih lagi wait and see. Kalau keputusan tu diteruskan, tak ada exam, I will still use that particular paper to assess your understanding up until now. So kita akan guna untuk assessment dalam kelas sajalah. Tapi kalau saya plan nak guna, saya akan bagi tahu at least 3 days before so that you can prepare better lah. Okay. So tapi jangan risau ya, kalau saya plan nak guna kertas exam tu untuk assessment dalam kelas pun saya bukan nak guna untuk rank siapa paling tinggi markah dia, siapa paling rendah. That assessment is for you and I. For me is for me to assess which topics that need to be readdressed, for example, to help you understand better. For you pula, you can use it to assess yourself how much content about science that you understand. Kalau nak go back to certain topics tu, tak adalah nak kena tengok semua topik, tak adalah nak kena study semua, kita boleh strategize balik topik mana yang that you require more help. That is the objective of the assessment lah sebenarnya ya. Sebab saya tak ingat siapa yang tanya saya semalam, so saya janji dengan dia, saya announce dalam kelas, so that's it lah. That's basically it lah. Kalau saya nak guna, saya akan bagi tahu at least 3 days before lah, so that you can be ready. Okay, let's take a look at your answer. So apa? The units that can measure background radiation, mari kita tengok. So the unit sekejap ya. Saya nak tengok sampel jawapan. Yang mana satu boleh guna untuk sampel jawapan. Sebentar ya. Okay, so nak mana tadi? Rasanya dah highlight dah tadi. Tak keluar . Okay, let's take a look at one sample answer here. So, the unit to measure the health effect of low levels of ionizing radiation on human body, unit dia tu ialah sievert, S-I-E-V-E-R-T. So, I agree with you. I also agree with you when you write the symbol as V. So, unit dia ialah sievert. So, kalau kita letak per hour, maknanya itu adalah dia punya kadar lah, dia punya rate. The rate of exposure to background radiation per hour kan, atau over time. So if you write sievert per hour, itu dah jadi kadar. Tapi the unit to measure is actually SV je lah, sievert ya. Okay, unit to measure ialah sievert. Tapi bila kita measure exposure to background radiation, kita akan measure ikut within a duration of a period of time. So sebab itulah dia ada per hour. Tapi dia punya unit ialah SV saja. Dia punya kadar baru kita sebut SV per hour. Kalau dia kata the rate to measure the health effect of low level blah 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 blah, baru kita tulis SV per hour. Kalau dia kata unit to measure saja, kita tulis sievert sajalah. Okay, so 1 sievert equals to 1 joule of ionizing radiation energy. Ionizing radiation pun boleh ya. 1 sievert is equal to 1 joule of ionizing radiation energy absorbed by 1 kilogram of living tissues. Okay, sievert ni boleh exist into smaller units, sama ada millisievert atau microsievert. Okay, sama ada millisievert atau microsievert. So bila kita tulis dekat normal and safe level of radiation tu is less than 0.2 microsievert per hour. Okay, so kalau kita tengok kat sini untuk statement number 3 tu, smaller units tu adalah millisievert and microsievert. Okay, kalau tak ada jumpa simbol micro dalam kita punya keyboard tu, tak boleh nak cari macam mana nak tulis simbol microsievert kan. Just type saja microsievert. Alright, sekejap saya tengok dekat sini ada tak yang dah tulis so that it can be a good sample answer. Okay, dia punya SIEVERT ya. So, normal and safe level of radiation tu ialah 0.2 microsievert. 0.2 microsievert. Okay. So, thank you Ifrah. Ifrah tulis Ifrah draw dia draw simbol micro tu. Very good. Satu lagi Ifrah ialah millisievert ya. Untuk nak statement number 3 tu, two smaller units tu adalah microsievert and millisievert. Thank you Ifrah. Alright. saya screenshot sebab saya tengok ada yang dia tak berapa jelas ya, cara nak tulis tu tak apa. Kita share daripada jawapan kawan-kawan, no worries. Alright. Okay, thank you for your submission, Ifrah. Okay, sekarang ni kita nak tengok pula. Sekejap ya, I give you another minute to update your slide. Boleh refer kepada Google Meet to see sample answer over there. Lepas ni kita nak tengok, discuss more about background radiation ya. Okay, sorry to disturb you. I would like to continue. Nanti I will change this slide into student pace. Nanti you can update your slide ya. So as mentioned by Ifrah just now, okay, the safe level of background radiation dose is 0.2 microsievert per hour. So dekat sini dalam this particular slide ni dia ada conversion ya, conversion of different units of sievert. Okay, the first one is microsievert. Yang second one tu kalau kita convert 0.2 microsievert tu kepada millisievert, kita akan dapat 0.0002 microsievert per hour. So dua-dua dua nombor yang pertama tu adalah nilai yang sama, cuma satu adalah dalam unit mikro, satu lagi dalam unit milli. So when the same amount of when the same number is converted into a longer period of time, which is year, dalam 1 tahun berapa exposure dia? So 1 tahun ialah 1752 microsievert per year atau 1.752 millisievert per year. So nampak banyak background radiation kat kehidupan kita ya. Dalam food ada, dalam building pun ada, TV, smoking, from cigarette smoke, and also medical procedure macam X-ray lah. Okay, here are another example. Okay, kalau high altitude berapa? Sebab when we are higher, closer to the atmosphere, we are exposed to cosmic rays kan. So high altitude, being outer space, being in a flight also expose us to cosmic rays. But in the environment also have background radiation around 0.4 to 1.0 microsievert per year. So okay lah kan. Okay, so these are a list of different sources of ionizing radiation dose. Ada background radiation, taking X-ray, TV, food contaminated with radioactive substance and cosmic rays. Can you match the source with the correct safety measures on the right? Okay, can you match the source with the correct safety measures? Yang paling obvious X-ray lah kan? Senang je. Okay, so number one ya, background radiation tu okay, use spectacles fitted with anti-UV film, anti-UV umbrella and others lah. So itu adalah safety measures sebab ionizing radiation yang ada pada kita punya background yang expose yang ada pada environment yang paling yang paling prominent adalah UV rays kan. So source nombor satu tu background radiation, dia punya step ialah use spectacles fitted with anti-UV film, anti-UV umbrella, pakai pakai sunscreen kan, all of this to reduce the effects of UV ray. Okay, untuk nombor dua, taking X-ray, safety measure dia of course lah kita X-ray is taken with doctor's prescription only kan, bila doktor suruh baru kita ambil X-ray. Okay, untuk nombor tiga, exposure from TV. Okay, untuk nombor tiga, exposure from TV, the distance between the TV and the viewer is at least 2 meter kan. Tapi itulah kalau kita pakai telefon untuk virtual reality macam mana pula ya? That is something to think about ya. Adakah dia punya radioactive radiation tu, background radiation tu adalah sama macam yang kita tengok sebelum ni lah, TV punya emission tu sama tak? Atau disebabkan telefon yang digunakan untuk attach pada VR tu size dia lebih kecil, maka background radiation dia lebih kecil? Nanti kita discuss ya. And then untuk food contaminated with radioactive substances, do not eat food in areas contaminated with radioactive substances lah. Sebab as mentioned in the first video, kita ada possibility untuk ingest radioactive materials kan. So kalau kita tahu the food is grown in areas with radioactive substances, kita jangan makan lah. And finally number 5, cosmic rays. Untuk the working hours of a pilot are limited. Pilot, cabin crew kena limited lah to a certain period of time. Tak semestinya pilot saja, cabin crew pun kena limit lah dia punya working hours due to the risk of excessive exposure to cosmic rays. For example, in this statement lah, kalau kita tengok kat sini, okay, semakin tinggi kita berada di udara, dekat atmosphere, the stronger the cosmic ray that particular individual will receive. That is why their working hours are limited to a certain period of time. Okay, so that is all for our discussion for today. Basically what we have discussed about ionizing and non-ionizing radiation, the characteristics of each types of ionizing radiation dari segi dia punya charge, dari segi penetration power, ionizing power, and then finally we have discussed about the sources of ionizing radiation. It can be from natural sources atau man-made sources lah. So what do you think of today's activity? What did you like? What didn't you like? What was easy and also what was hard? If there are any parts of today's discussion that is hard for you, please write it in what was hard so that I can address it tomorrow. Esok kita ada kelas kan? Oh, you like yourself. That is very good. Yes. Appreciation, self-appreciation day. Yes, we have to like ourselves before we like others kan? Everything was pretty easy. That is good. Alright. Oh, kind of confusing. Nanti tulis kalau kind of confusing tu confusing part mana ya? Oh, okay. Confusing part mana? Yang untuk essence for this particular subtopic adalah characteristics and also characteristics of ionizing radiation. Lepas tu juga adalah sources of ionizing radiation lah. Oh, okay. Nanti kita discuss. Ada dua event yang berkaitan dengan nuclear radiation yang besar lah. Nombor satu ialah the effects of tsunami on the nuclear plant in Japan. Itu yang paling recent, yang yang lama dah berlaku tu Chernobyl lah. Itu yang sampai jadi apa mini series dalam Netflix kan. Netflix ke HBO tak ingat. Alright, so saya akan tukar slide ni kepada student pace sampai esok sebab saya nak tengok apa lagi kamu punya reflection untuk hari ni lah. Apa mana lagi yang susah atau challenging untuk kamu. So what is the difference of micro or milli? Alright, very good question. So thank you so much for attending our class today. Hopefully you will have a good week a good week for today. Hopefully you can easily understand all of the lessons that you will go through this week. So that is all for today. Thank you so much, and I will share with you the attendance link later ya. Sekian wabillahi taufiq wa hidayah. Assalamualaikum. See you tomorrow.
Thank you, teacher.
Thank you, teacher.
Thank you,
You're
teacher.
welcome.
Thank you, teacher.
You're welcome. Have a nice day. Ngantuk ni.